Hey guys, welcome back to my channel, and now we will summary the chapter 6 entitled Network Layer. So section 6.1 Network Layer Protocols. The network layer is accomplish this. The network layer allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes. So this is the four processes: the addressing and end devices, encapsulation, routing, and the encapsulation. Addressing and devices. And devices must be configured with the unique IP address. Encapsulation the transport layer to into a packet. That's the encapsulation. Routing, to travel to other networks, the packet must be processed by a router. The encapsulation is after the packet is encapsulated by network layer, the resulting layer IPv layer 4 VDU is passed up to the appropriate service at the transport layer. Unlike the transport layer, which manages the data transport between the process running on the network, running on each host network layer. Let's play this video. Let's see the movement of data segment. Yeah, encapsulation, going down to encapsulation, and it will data link or frame going to physical and routing. So encapsulating IP. The IP header remains the same from the time the packet leaves the source host until it arrives at the destination host. The process of encapsulating data layer by layer enables the services at the different layers develop and scale without affecting the other layers. Let's go to the routing. Host forwarding decision. So you must see the host forwarding decision. Another role of the network layer is to direct packets between hosts. Itself, a host can ping itself by sending a packet to a special IPv4 address of 127.0.0.1, which is referred to as the loopback interface. Pinging the loopback. Local host, this is a host that the same local network as the sending host. The hosts share the same network address. Remote host, this is a host that a remote network. The hosts do not share the same network addresses to other person like that. Whether a packet destined for a local host or a remote. Of course, in most situations, we want our devices to be able to connect beyond the local network segment, such as out other homes, businesses, and the internet and other services. Routers. A router is a computer. There are many types of infrastructure routers available. In fact, Cisco routers are designed to address the needs of many different types of business and networks. So this is branch. Telework small businesses and medium-sized branch include Cisco integrated services routers. 1. Large businesses, organizations, and enterprises includes the Cisco Catalyst series switches and all Cisco aggregation. Service provider. Large service providers include Cisco ASR. The focus of CCNA certification is on the branch family of routers. The figure displays the Cisco 19s and 29,000s and 39,000 G2 integrated services. So this is the acquire routers, central processing units or CPU, operating system or OS, memory consisting of random access memory or RAM, read-only memory, the ROM, and non-volatile random access memory or NVRAM and flash. That's for the router. That like router is a computer. Basic switch configuration. Cisco routers and Cisco switches have many similarities. They support a similar operating system, support similar command structures, and support many of the same commands. So this is the full summary of Chapter 6, the network layer. The network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the internet is largely based on IPv4, which is still the most widely used network layer protocol. An IPv4 packet contains the IP header and the payload. However, IPv4 has limited number of unique public IP addresses available. In addition to hierarchical addressing, the network layer is also responsible for routing in a host require a local routing table to ensure that packets are directed to the correct destination network. The local table of hosts typically contains the direct connection. The default gateway is the IP address of a router interface connected to the local network. When a router, such as the default gateway, receives a packet, it examines the destination IP addresses to determine the destination network. Routing table and tiers can be configured manually on each router to provide static routing, or the routers may communicate route route information dynamically between each other using some routing protocol like that. In order for routers to be reachable, the router interface must be configured to enable a specific interface. Enter interface mode using the interface type and number global. If the router has an entry in its routing table of the destination network, the router forwards the packet. If no routing entry exists, the router may forward the packet to its own default route. If one is configured, or it will drop the packet. Because routing have a table entries that be configured manually. Each manually provide to static routing like that. You don't if when a host needs to forward packet to destination address that is not the same network as the host, the packet is sent to the default gateway for further processing. So that's all for my summary of chapter 5 entitled chapter 6 entitled network layers. So thank you for watching my video, and subscribe and like my channel, and that's all for my video. Babush, thank you.